So while my class is just working away in the background, first triangle had coordinate of 2, 8 up here and 3, 27. The height was the difference between 27 and 8 was 19. The width was the difference between the 2 and the 3, which was 1, and that gradient came out to be 19. The next triangle, I've got the x coordinate being 2.5, which means the y coordinate is 15 and 5/8. The gradient will be the difference in the y coordinates, which is 15 and 5/8 take away 8, over the difference in the x coordinates, which is 2.5 take away a half. That gives you 7 and 5/8 divided by a half, and that comes out to be 15 and a quarter. So the next thing I'm going to ask them to do is to look at the triangle where the bottom left coordinate is 2, 8, and the x coordinate at the top is 2 plus h, where h is small. So they will then have to find the y coordinate to go with this, which will be equal to 2 plus h all cubed, and then they'll have to go and do the same thing on that. The final triangle we're doing here then is the one with the distance of h along the bottom. The first coordinate is going to be 2, 8, and if I go along h, then the x value here will be 2 plus h. And because I'm looking at the curve y equals x cubed, the y value will be the x value cubed, which is why I've written down here 2 plus h all cubed. So I need to work out what this 2 plus h all cubed is by multiplying out the brackets. It means 2 plus h times 2 plus h times 2 plus h. If I multiply these two brackets together first of all, I will get 4 plus, I'll get 2h there, another 2h there, that'll give me 4h, and h times an h will give me an h squared. So multiplying the first two together, same way as we did the last one, that's what I get. Now I need to multiply these together, and if you're not so sure about doing these, first of all I'll multiply everything in this bracket by the 2. So this becomes 8 plus 8h plus 2h squared. Then I'll multiply everything in the first bracket by a positive h. So I'll get 4h squared, and h cubed. Then what I want to do is to simplify that by gathering my similar bits together. Bits with no h's in at all, it's just that 8. Bits with an h in, 8h and 4h is 12h. H squared bits, there are 2 there and 4 there, which is 6h squared. And I've still got the h cubed. That means the coordinate at the top here of this triangle on the curve is going to be 2 plus h and 8 plus 12h plus 6h squared plus h cubed. That will be the coordinate at the top. Okay, so we've got now this top coordinate. So what I want to do now is to find the gradient of the line. The gradient of the line, even if you go back to a formula we had before for the gradient of the line and you want to use it, we can do. Shh. Can we be quiet down here, please, Luke? Shh. Right, it is the y coordinate at the top, which we've just worked out, was this: the 8 plus 12h plus 6h squared plus h cubed. Take away the y coordinate at the bottom, and the y coordinate at the bottom was 8. The x coordinate on the right was 2 plus h, and on the left was 2. So on the bottom it's 2 plus h, take away 2. This is a fraction you will get that will give you the gradient. That take away 8 will cancel with that 8. That minus 2 will cancel with that 2, just on those lines. So the sum we get is 12h plus 6h squared plus h cubed over h. In doing what we did last time, we can factorise this top bit. There's an h in each bit. If I take h out as a factor, h here is multiplied by 12, h here is multiplied by 6h, and h to get h cubed is multiplied by h squared. So the fraction I get is that. Then I can cancel those h's. So I get eventually 12 plus 6h plus h squared is equal to the gradient. And remember, h is something that is very small. When you square something very small, well, just think of a small number. 0.01 is a very small number. If you square it, you get 0.0001. You get something even smaller. So something very small squared is something even smaller. This is something small. 6 times by something very small is still very small. So what we can say is this. As that h gets very, very small and tends towards 0, the gradient, which is this thing here, well, as h approaches 0, that approaches 0, that will disappear, because something very small squared is something very small. And as the small bit is approaching 0, effectively you can think of that as 0 squared is nothing. If this h is getting so close to 0, we can think it's 0. 6 lots of 0 is 0. And we're just left with the 12. So what we should just have discovered is on the curve y equals x cubed, at the point 2, 8, the gradient is 12. Now we could go through this process for every curve, but it would take forever. So what we're going to look at next is a way of getting from your curve and your coordinate straight to the gradient itself. The way you can get straight from the curve to its gradient function is called differentiation, and that is a topic we're sort of going to be looking at now. Today we started looking at the curve y equals x cubed, and we looked at the point on that where x was equal to 3 to start with. And we worked out earlier that when x was equal to 3, the gradient itself was equal to 6. Now just think, what did we do to the 3 to make it into 6? Okay, some people are saying we times it by 2. Have a look at that in a minute. Leave a little gap underneath there, please. Next one we looked at was y equals x cubed. And we looked at what happened when x was equal to 2. And when x was equal to 2, we worked out the gradient was equal to 12. Okay? What did we do to that 2 to make it become 12? We times it by 6. And we've got to see if we can work out how we can get these things from the things over here. Now, if I tell you, here we've written down timesing by 2, that means we times the x number by 2. I'm going to write down over here, that is 2x. And we actually have, if the curve is y equals x squared, the gradient of that curve is always twice the x value. For x cubed, you might think then, in that case, because we times by 6, it's always 6x. If we did some more drawings, I can actually show you it wasn't always 6x. Can somebody who has done this before tell me what it is? Hannah? It's 3x squared. Okay? That one goes to that one. Haven't explained why at the moment. Don't worry about that at the moment. Haven't explained why. Hopefully in a minute some of you will spot a pattern. Yes. Next one. If I started with the curve y equals x to the power of 4, and I told you the gradient for that was going to be 4x cubed, so whatever the x value was, if you cubed it and times it by 4, can anybody tell me what it would be for y equals x to the power of n? Just look at what we've got so far. How have we got, do you think, from cubed to that, which also works here to there? Rob? Okay, let's have a look. Here, that 3, that power, has come down the front. So that 4 appears at the front. So it seems sensible to put that power at the front. The power of 3 here became a power of 2. The power of 4 here became a power of 3. The power of 2 here actually became a power of 1, but we didn't write it in. And that is what we get. Now we've got to try and work out as well how this is linked into what we got earlier. And what I wanted to look at next is a general curve. We've looked at x squared curve. We've looked at the x cubed curve. What I want to look at next is this curve and see how we can end up getting this function here.